Morning all. I hope that you had a wonderful session on the first day of our short-term training program. So today we are in the second day of our STTP blockchain application. Today's session will include blockchain in digital forensics by Mr. Access Summit Learning, decentralization identity by Dr. Mukesh Mohania, and game theory in DeFi by Mr. Harsh. The speaker of the first session, Mr. Akisham Lomi, is a research scholar in the Department of Computer Science and Engineering at NIT Srinagar. Prior to joining NIT for his research, he has worked as an assistant professor at Islamic University of Science and Technology. He has published more than 50 research articles in various research journals and authored more than 90 patents. His major research interests and skill sets are cryptography, network security, web application security, digital forensics, and blockchain. He has also completed various blockchain certifications, including IBM Blockchain Foundation for Digital Network. Mr. Akif has completed his master's in information security and cyber forensics from Jamia Hamdard University, New Delhi, with University Iran. He is sheer enthusiasm and expertise in the field of blockchain and digital forensics. For this session, he is going to deliver an interesting session on blockchain and digital forensics. Over to you, Mr. Akif.
Thank you, ma'am, for your generous introduction of mine. I hope my voice is audible.
Yes, sir.
All right. So should I share my screen?
Yes, we can.
Yeah, sure. Is my screen visible to everyone?
Yes, sir.
Okay. All right then. Once again, thank you for the generous introduction of mine. My name is Akib Hamid. I'm a senior research fellow at NIT Srinagar. As part of research work, we explore blockchain potential for beyond cryptocurrencies applications in sense. So basically, we are trying to use blockchain for enhancing security and trust. Today in this session, I'm going to talk about blockchain for digital forensics and cybersecurity. Most of the talk will be, covering digital forensics, application of blockchain for digital forensics. So let us start. So first of all, we define what is digital forensics. If we define digital forensics, it is a scientific process of identification, preservation, collection, and reporting on digital evidences that are related to any cybercrime investigation. So one of the important features, one of the important part of this digital forensics is digital chain of custody. So what is digital chain of custody is actually, recording the defined processes that we have taken while investigating a cybercrime in a chronological history of handling the digital events. We need to document that. So this is digital forensic chain of custody. So basically, we are trying to exploit blockchain for building up this chain of custody in order to ensure authenticity, integrity, transparency, and auditability into this chain of custody. Because what we traditionally do, we use paper-based chain of custody to document all those transfers, all those very minute records that are very, very important in the admissibility of the digital evidence in the court of law. Right. So if we see the life cycle of this digital forensics, we see there are different types of events happening all along the life cycle of cybercrime investigation. If we see the first step of is to identify, first step is to identify and prepare for cybercrime investigation, under which there are several sub processes happening. We have to recognize the incident, what incident has happened. We have to ensure the tools that we are going to use for investigation. We have to, get the legalities of all the search warrants and authorizations that are required. After identifying and preparation for the cybercrime investigation, and then we have to, search and seizure, we have to recognize evidence, and then we have to collect that evidence. Then we have to preserve that, we have to secure it, we have to protect the integrity, because these digital evidences are, latent and they are fragile, they can be just easily modified in, against. Then we have, after preserving it, we have to examine it, we have to, sometimes, because we are not dealing with the real evidences, we have to just duplicate it, because this is very sensitive matter, because we are investigating a cybercrime here. So what traditionally, cyber forensic investigators are doing, they are just duplicating the evidences, then they are recovering what is important and what is pertaining to this cybercrime, so that they come up with the proof that this cybercrime has happened at this time, and who is the main culprit. Maybe this is a very sensitive step in digital forensics, because examination involves several things that are very sensitive in nature. Then after examining, we have to analyze it, we have to determine its significance, we have to reconstruct the fragments that are, really relevant to the present cyber crime. We have to report, we have to summarize it, we have to translate it, we have to explain each and every step, so that all the digital evidences that we have collected are admissible in the court of law. So basically, all these steps require the documentation process, very important process, that we normally call as chain of custody, that is sitting in the middle of this diagram. You can see here, this is chain of custody. What we try to do, we have to just, use blockchain to simulate that process also. If we see the life cycle of digital evidences, it is, again, very relevant to the digital forensic itself. We first start with the collection, examination, analysis, and analysis. We can go again collecting further digital evidences and then examine again, or we can examine after analysis again. Then we have to report it, we have to prepare a court trail, and finally there is a settlement process that concludes the life of a digital evidence. So what is the motivation behind using this blockchain for this digital forensic process? See, there are subtle differences between digital evidences and the physical evidences. Digital evidences, if we say, they are very hard to handle and preserve because of their, very fragile and latent nature. They can just change very instantly, and they can cross, borders within no time, because if we have some email traces, we can delete it within no time. But it is corresponding to this digital evidence, physical evidences are very hard to, eliminate. If handling itself of digital evidence poses several unique challenges, because there are lots of things involved in it, because of their, again, very fragile and latent nature. The chain of custody that we are currently using in the forensic process is inefficient in a manner, because they don't ensure the guarantee of transparency in a sense, because it is a paper-based thing. Manually they have to just write each and every incident in an event. Now, another step in this is that reliability of investigation outcome is very, heavily depending upon the correctness of the forensic tools and the application procedures that we are using in order to, investigate the cybercrime. Because, tools are very important, because we have to ensure the integrity of the tools itself, the functionality they are performing. Suppose we are using a tool for, preparing a hash, or, calculating the hash. So we have to ensure that it calculates very, accurately. So in addition to the chain of custody, the reliability of investigation process is also dependent on the correctness of the tools. So what is the requirement is to have an automated system that guarantees auditability, transparency, integrity, and authenticity. So fortunately, we have a blockchain here that has these unique features built in. So we can easily exploit this to build a very solid digital forensic investigation framework. in order to handle digital evidences very effectively and taking all the stakeholders into account in investigating a cybercrime. I hope my audio is audible to everyone.
Yes, yes.
Yeah, okay. So if I'm going very fast, please stop me, everyone. I'm here asking you. And
You
if
are in,
anyone has any question in the middle, no problem. He or she can stop me at any time. So
you
can
are in proper speed. You are in proper speed. Please proceed.
okay. Thank you very much. So before using the blockchain, we have seen yesterday we were having some sessions on blockchain applications without thinking of doing something, on blockchain. There are certain very subtle questions that we need to ask ourselves before, using blockchain for certain applications, because, at the end we require efficiency and we require, budgeting also. We have to minimize the budgets, we have to use efficiency, we have to several other parameters we have to take into the consideration before using blockchain, because blockchain is not fit for everything. There are certain problems that can be solved with the blockchain. So there are multiple you know frameworks that help us to evaluate whether we should use blockchain or not. In this diagram, this is the model proposed by Arthur Gravis, and this is just a slight modified model of their work. We have a chain of custody because what we are trying to exploit blockchain to build chain of custody in forensic procedures, in forensic, in broader sense of digital forensics. So we have a chain of custody. We have to ask certain number of questions about this chain of custody. If they qualify, then we use blockchain. If they qualify, then we don't use it really, because we don't want to make it inefficient, corresponding to the present available solutions we have. So the first question is there any requirements of storing the state? Yeah, of course, because if we take a simple example of storing the state, it is just a bank account where we have a state. Our account is a state. When we do transactions, it changes to, next state. It's like a state transition system where transactions are, actors which transfer one state to another state. So in case of digital evidences, there are, multiple artifacts that are important and corresponding to the digital evidence. So when we just start investigating cybercrime, right, this digital evidence follows a certain hierarchy of officers which are in charge of handling the digital crime or the cybercrime. So it starts from the first responder to the judge that finally settles that digital crime or cybercrime. So in a sense, I want to say that there is a requirement of storing the state of digital evidence. So the answer goes yes. Then we have a question two. Here, if we see, there's another question two. Do we have multiple writers in the system? This is very important, again, question, because if we don't have writers, because problem comes in where there are multiple writers writing, because we have seen the classical read write problems in academics. We have seen it in bachelor subjects. If there are only reads, there's no problem at all. But when there are writers writing simultaneously, on a certain system or a certain state, then it creates certain problems. And we have to ask ourselves before using blockchain whether there are multiple writers in the system or not. So of course, because there are multiple investigators, investigating a single digital or cyber crime. So the answer again is yes. Then we move to question third. Right. Can we afford to have trusted third party online always? See, what are traditional systems built on? They are built on centralized, security mechanisms. Like if we see, we have STTPS, the TLS, we have certificate-based systems. We see there is a trusted authority that issues those certificates. So we put our trust on the third party here. So if we can afford to have that, then we can think okay, fine, we have that leverage here to exploit, but still, there is a slight modification in the question third. If we see, okay, fine, they are trusted right away, but who guarantees about their trust in the future? So that's what blockchain makes it beautiful technology to use for enhancing trust in traditional applications where trust is required. Because here we say, okay, fine, we have third trusted party, we can trust the third party here, and we can get everything done. But no one can assure or guarantee about being trusted again in the future and doing all the things what they have written in the document or what they have planned to do. So again, if yes, still we say, okay, fine, we have this leverage we can use, so we don't require to use the blockchain then. But the question is, because it is very costly thing to have trusted third parties having online each and every time 24/7. So we move to question number 4, because the answer is no here. We ask again, all the writers known in the system. If they are known, fine, then here we differ on the application which blockchain we have to use. Because if they are known, then it is a case of using permission blockchain, whether it's a public permission, whether it's a private permission. Because if they are not known, then the beautiful example of this is Bitcoin, where everyone is free to join. No one is to be known in advance. So for that sake, we use permissionless, because this forensic process happens in very, very constrained environment. So the best thing is to use permission blockchain, whether it's a public permission or it's private permission. So finally we have 6. If there's question number 6, if there are any requirements of public verification, again we require it, because we want to verify each and every investigator before he is allowed to investigate the cybercrime. So finally we can use public permission, or it's a choice that we can take on seeing the benefits that we can get from these two possible options. So finally we came to conclude here, yeah, this chain of custody is a potential candidate that can be, we can leverage blockchain to build this chain of custody by doing a feasibility test on this particular application. And this is not for this only, because I suggest each and everyone who is exploring this blockchain space to just verify whether we really require blockchain to to target any particular application. So we have certain number of questions. These questions can also work, but there are other requirements for other particular applications that we need to take on. So from this slide, we can conclude that, yeah, blockchain is the perfect candidate for building the chain of custody. Okay, so why blockchain then? Okay, this is a candidate, but why blockchain? So I assume, man, the maximum participant have background about blockchain fundamentals. It's not a problem if someone is not having, but if anyone is having any doubt about blockchain, you can, at the end of this, when I just finish it, you can ask. We can just discuss on that also. So, or he or she can stop me here, and I can explain that concept even here. What is blockchain known for? Blockchain has by design, it guarantees authenticity, integrity, transparency. These are very critical features, and that maximum technologies were not able to provide us before the advent of blockchain. So particularly, blockchain helps us to have a proof of state. So what is that state? That state can be defined with the multiple parameters taken into account. If we say blockchain gives us proof of existence, of course, because it allows us to verify whether certain thing has happened at certain particular time with an authentic timestamp. Right. So again, the second thing it provides us, it's a proof of ownership. because these are very important features. These helps us to identify blockchain applications beyond cryptocurrencies, because if blockchain is used for proof of ownership, again the beautiful candidate for this is putting land records on blockchain, because it helps us who owns what, under what circumstances this transfer has happened. So these are very important features of blockchain that we need to understand before building the blockchain applications. Again, the integrity, because there is a cryptography that we have listened from esteemed professor yesterday. There is no double spend. No one can, because of the consensus mechanism, no one can cheat. It again gives us proof of provenance, history of owners in the past time, because it records. If we see the technical definition of the blockchain, it is like a data structure encumbered linked list. But this list is, here we have a special data structure called as block, where one block is connected to previous block with the hash. So with this hash, it gives us integrity, and provenance is there because we can prove each and every action that has happened in the in past, if that's on the blockchain. Traceability, these are very relevant features, but trail of movement, what has happened, because this feature traceability helps us to build a chain of custody, both in digital forensics, in supply chain management, each and every application. If we can think, these are the best features that we exploit by building applications on the top of blockchain. Right. So we have seen why blockchain gives us these set of features. Again, if we I have just shown before this one diagram, first where I explained the basic process of digital forensics. Here I have replaced that chain of custody with the blockchain. This is what blockchain brings in. We have to, now we will see what are the certain functionalities that blockchain will provide here in order to guarantee authenticity, integrity, and auditability in the digital forensic itself. Okay, so this is a simplified architecture that I propose as part of the research, where see, these are the participants here. They can be first responder, immediate forensic investigators, prosecutor, defense, court. Each and everyone can be here. And sorry, we have this smart contract or a chain code, because it really depends which type of blockchain we are going to use. If we, in generic sense, there are smart contracts that that simulate the functionalities that we require in order to build the chain of custody based on blockchain. So what they do, they just provide, we just record that actions, and whatever there is a transfer, there is modification, there is evidence collection, everything will be recorded very efficiently with the help of this blockchain. And finally, we have a consensus mechanism that we have seen. What blockchain is built on three basic core technologies. We have P2P network, we have consensus mechanism, we have cryptography, we have game theory coming together to build this beautiful technology. So with this, we get a blockchain where blocks are generated with certain amount of time, certain defined depending upon the type of blockchain that we are going to use. And each block is, proceeding block is having a special pointer called as hash pointer to its previous block. Here we see the simplified architecture is here, where block 4 is pointing to block 3 because it involves the block 3's hash. So if there is a slight modification on any of this hash will change and it will break the chain. Okay. So I hope this slide is visible to everyone, because it doesn't fit to the screen.
Yes, yes.
Visible, sir.
Okay. See, this is the operation flow of the forensic chain that we developed here in NIT. We have creator, that's the first responder who creates the digital evidence. We have owner, maybe at the first time when creator creates it, he is the owner itself, but after a certain amount of time he may require to transfer that digital evidence to some other participants, some other forensic investigators, if we talk about forensic chain. So then that investigator becomes the owner, and there are other participants in the network that we have seen in the previous slide. There may be judge, there may be certain other investigators that are investigating the cybercrime. There, this can be, this whole diagram can be divided into basic modules. We have participants, we have front end, that is the part of the development where we require to build a DApp, a decentralized application, that will just provide the interfaces to the smart contract functions that are being developed. So then we have core modules that are actually the smart contract functions, and these actually work on top of blockchain. So there is a peer-to-peer network, there is consensus going on, there is, with the help of consensus we get blocks, and blocks build the blockchain, and there is certain distributed evidence stored, because here the one important thing is here, we don't store the real evidence into the blockchain, because blockchain is not a database. We have to take care of this. We have to set minimal amount of data into the blockchain so that it doesn't become the bolt to the blockchain and limits its scalability. So in further slides in the session, I will discuss about those problems that we are facing. So we require the traditional authentication authorization, but in future work, this authentication authorization has to be removed with the blockchain itself, blockchain based access control mechanisms. Right. Okay. So should I say the demo first, or I should complete the presentation first? The is yours, because there may be other things that are relevant to this. Okay, we finally at the last we will see a demo, right?
Sir, we see demo first, sir.
Yeah, I
Okay.
want, sir.
Thank you, sir.
Demo, sir.
Okay, no problem at all. So I have to share my browser, because see, there are multiple ways to simulate things. Like we have Truffleshoot for, we have Ganesh for as a blockchain simulator. We have other, but we here in NIT we have built our customized blockchain based on Ethereum with customized consensus mechanisms, and modify the proof of authority and just integrate with the Ethereum blockchain. But for the generosity and for the simplicity, I have used a browser based remix. Most of the people may be knowing that, so that we can simulate it easily. And we are simulating a small part, that is chain of custody, because it is a huge project where we need to do multiple things at right. But whatever I have spoken about chain of custody, I have simulated it, and let me share my browser. Okay, right. So basically, yeah. Is it visible now?
Yes, sir.
Yes, sir. Yes, yes.
Okay, it's a browser, my browser here. Most of the people are knowing about Remix. If not, please say me. I just want to I will give some thoughts on Remix. It's a browser-based simulator, right? Where we have very effective simulator, because it allows us to connect to the any blockchain, and it has a JavaScript-based blockchain built itself in the browser itself. So I am exploring that only here, because we don't want to make you to install the softwares. It takes huge amount of time. So we can simulate each and every stuff here. What I did, I created a smart contract for chain of custody, right? So I need to simulate certain things. Like first we have a evidence may be having a different structure here, because for general purposes I use it. There is an ID, that is we can use hash function to generate this ID. There is an owner who is first creator and owner are the same persons. and these are addresses here. This is what makes Ethereum more powerful than Bitcoin, because the smart contract is Turing complete. Turing complete means we can, simulate any logic that we can think of, because they are programs depending upon certain conditions. Just in case of Bitcoin, there was a restriction of block size that we cannot have a transaction, and there are not all programming constructs that we can use to build any logic. Here we have those, but we are limited by the gas. So that's a technical part. Maybe that's part of the blockchain fundamentals. So we need to do transactions with the size, limited size, and the gas they involve. Gas is just a computational cost. We cannot build anything like, do the for loop for infinite amount of time, then it will bolt this blockchain. So starting with this chain of custody, we have a very simple string case ID, which case we are just handling in. We have evidence as a structure and a programming structure, like different sort of parameters are there, and we have variables like the description. This may be a JSON, important artifacts pertaining to the digital evidence that are coming straight away from the tools. We are just taking them here, and there is a address array that is used to maintain the trace of each and every forensic investigator who is acting on this digital evidence. There is a, time, again a time array, because we want to have a timestamp on what time any participant has performed any action on the evidence. We have to just take it. I'm submitting bare minimum functionalities here, and I'm leaving you can add here multiple certain other functionalities that can make it complete. Another, we have a structure forensic investigator that can have multiple characteristics that we know. The organization who is handling the cybercrime, the any unique ID that will recognize the person within the organization. Right. Now we have to first register those investigators. For that, I have developed here a register investigator. Right. So whosoever is, in calling that function, that is, that will pass two parameters here, an organization and the ID, and they will be, set here, because I have done a mapping here, because first we need to say that this here it's a mapping that maps forensic investigator data structure into address. So we can use this is actually a key value pair, where the address is the key and the value is the forensic investigator details. So what we are mapping it here. We are mapping the organization to this investigator, whosoever has come, because whoever invokes this message.sender will be the address of that person or that investigator. So this part completes here. Again, we have a constructor, because we are, deploying a smart contract per case basis, because this happens only once. When we deploy the smart contract, we are passing the case ID there, so that sets the platform for us, because this will be the case used for particularly for this cyber crime case or investigation case. So just like a Java classes where we have to create multiple instances, the template is here, we have to deploy it, and we will get the next instance straight away for different cases. So it will change, because it is whosoever is deploying is the person of authority. In further slides, I will show the future prospects that we are going to develop here. That has a lot of features than this. It's a bare minimum thing. Okay, so again, there is not a single evidence. We are having multiple evidences, and they have to be recognized with some unique keys. Like for this, we have designed a mapping that this unique bytes 32 is a data structure used in Solidity here. So it maps to evidence. Evidence we know, because at the top we have seen there are multiple things in the evidence. So with this bytes 32, we can get the evidence details, or we can set the evidences with this bytes 32. In the next function, there is a modifier. These are very important things in Solidity, because at the end you don't want to you don't want to anyone to just create the evidence and use that evidence or view the evidence nature. So for that, because we have seen it is a simple code, because we can develop lots of modifiers to make it proper, to make the functionality of this chain a proper thing. So here we say, okay, there is only creator. Only creator means, like whenever someone wants to create the evidence, it should be only the creator. Creator means whosoever has created this, had deployed this smart contract. For this, we require this, because it checks whether this the invoker of the message or invoker of the function is the creator of that evidence, right? So this modifier we can use for transfer, we can use for certain other things. Okay. Then another modifier is evidence exists, because we don't want to have a duplicate evidences. We will first check whether it exists or not. So if it don't exist, sometimes we may require that it shouldn't exist. Sometimes we require it should exist, because whenever we see, we want to just view the evidence at that time, we want that this evidence should exist. Whenever we create it, we want that this shouldn't be existing already there, right? So for this is a code that simulates that functionality. Now there is an event. Events are very important, because it provides us interface to connect with the outside world from the blockchain, because we have a dApp that is a front end. These events allows us to capture the results of smart contract smart contract functions. Okay, now this is the main function where we create the evidences, right? So here I have not used any, like, because we can use modifier only creator or only, because we can set it that inside the constructor itself, because whosoever is deploying will be the owner, and he will be only allowed to create the evidences here. So what we provide certain details, and we use catch 256 as an hash function to calculate the bytes 32, and we use this id bytes 32 to set all the details of the evidence. And here are those lines for sending message to sender, because first time owner and creator is the same, and description is the JSON artifacts relating to the digital evidence, and with this we get that ID, because we have used this description as the input to the function, hash function. And we have arrays that records who is the owner and what is the time now, because we can use a push function here. We have seen, we have already defined the evidences data structure TR and TT time. I hope man, everyone is following me here. If anything is to be explained, I will explain here, because after that I am going to deploy it and I can see the functionality in practice. Is it okay till the things that I have explained already?
Yes, sir. Yes, sir.
Okay. There is a function transfer that transfers the digital evidence from the real creator to the new owner now. And for that, it requires an ID that is recognizing the digital evidence uniquely to the address, new address to whom and the person wants to transfer, investigator wants to transfer. At the same time, we want this time, this should exist evidence, because we are transferring it. So it should exist, and we pass that true value here. So evidence.owner is the new owner now. Evidence.address is the new address, new owner's address currently, because this is an array, it will have the previous owner also. That is the chain of custody that we want to just simulate through this blockchain. And we have the time that is currently we are doing. Okay. So finally we have show evidence that will help us to identify the audit trail, who has transferred evidence and at what time, and who are the current owner and each and everything, right? Should I deploy it now, or anything to be explained here? It's a bare minimum functional. In next slides, we'll see there are multiple things, multiple features that we can associate, we can build on this. should I move towards compilation process, or anything is required to be explained here?
It's okay, best. Yes.
Okay. So most of people here are knowing how to compile it first, and I have this, and we have a Solidity compiler here. You can select anyone that is compatible. The code should be compatible with that compiler version. So by default, we have a 0.6.12 commit version of the compiler here. Solidity language is Solidity. There are other languages here that we can use. There is Viper also. That is also a good language, but most people are using Solidity because of its resemblance with JavaScript, and somewhat very not so close to Python, but the code is available, the support from the developers, because a lot of people are doing development on Ethereum, and they are mostly using Solidity, and there is a well documentation presented in the website of this Solidity. So it's very easy to use language for writing smart contracts. So for deploying it, we have to use any Solidity compiler, because actually we are working with Ethereum virtual machine. Just like in case of Java, we are using Java virtual machine. We need to have conversion from higher to bytecodes, any particular language that EVM understands. Okay, so after selecting appropriate things, I'm hitting compile here. All right. After compiling it, I have to go to the deploy, right? So this is very important here, because each and every functionality we have to understand here. There are certain environments, like we have JavaScript virtual machine that we are going to use. We have Web3. We can have any front end to connect it with the blockchain, customized blockchain. We can use injected Web3s. We can use test nets. We can use public Ethereum. We can use, there are certain other Ethereum types, test net types, like we have Rinkibi. There are other proof of authority blockchains that we can connect. Here we are using built-in Java virtual machine. So I'm selecting that. And by default, it is, giving us some accounts, like I think it's 10 accounts here. So in the customized blockchain, if we are using, we have to use this manually. So here I'm selecting the first account as the authority who is authorized to deploy and build the chain of custody first. Maybe any investigation agency, officer in charge, or any FBI, CBI, any investigation agency that can do it. And the gas limit is by default. Here we need not to dig deep into it, because this is a huge topic in itself. It takes a lot of time to explain what is this gas limit again. So after compiling, we have got this, because chain of custody is here. So I have told you that, because in constructor I have used one parameter, because case ID. Let's suppose that this is case ID is 123. It's a string. So case ID is 123. I'm deploying with this. Okay, and an option to publish it to IPFS. In later slides, I will tell you what it is. Okay, so I'm deploying it. Okay, fine. So we have finally successfully deployed it to the blockchain here. So we can get lots of things from this. This is the contract that we have developed, and contracts are recognized with the address itself, just like in case of external accounts. So we have an address here. So we will get a lot of things from this. Now the first function is create evidence. That requires a JSON file or any important features of digital evidence artifacts that we have to pass on it. Okay, maybe anything that you wish to pass on. Maybe these are logs or anything. This is a customizable thing. You can enter anything here. For simplicity, I'm just saying logs. Okay. I'm hitting transact. Okay, this is done. I'm not registering any investigator here. That's one functionality that I'm skipping here. You can instruct, you can add on many other functionalities. I just want to show how to transfer those digital evidences and build the chain of custody here. Now, we can transfer this, but for this we require an ID. And since this function returns a bytes 32 ID, so that may be in the output. Okay, here we have the decoded output here. So this may be our ID to recognize this digital evidence now. Now, before transferring it, I have to pass on this ID and the address of the new owner whom I wish to transfer it. So for this, I have to select another account to whom I have to transfer. Let us first copy paste it here. After that, I can easily copy address of another investigator. I'm not interested in this. So here we have bytes 32, perfectly all right. I have to copy, like we have another investigator into this investigation. I will copy the address of the investigator, but this can transfer. If I just select any other account, that will not be able to transfer because it has to be an owner, creator first to transfer this, because we have used that, solidity modifier to ensure that we have a new owner here, right? And I'm hitting transact. Let us see, is it successful? Yeah, successful here. So address new owner, we have passed on those 2 bytes and address forms. Now, if we see the state of this evidence right now, after doing one transfer, we have transferred this to some other thing, and we can use bytes 32 to see what is inside this. See what is happening. So we have an array of time. These are Unix epoch time from 1970 in seconds. So first we have this. This was the time when this digital evidence was created. At that time, we have the first address that was the real creator, the first creator of this. That's the creator of this evidence at that time. And the second time, just I have transferred it this. So we have another timestamp. At this time, we have transferred it. And this is the new owner of this. If we can continue with transferring it, we can get this beautiful chain of custody, because it exploits all those features that blockchain provides us with guarantee of trust and security, because the consensus is there that helps us to reach to this. Because if there is not agreement by maximum, if we use different consensus mechanism, if maximum validators oppose it, then this transaction won't happen. So this was a very small demo on this. And now there are lots of things to be done in this, because this is a work in progress, and multiple researchers are simultaneously working on it. I started this thing in around about 2017. The one I have published a very basic concept paper. Then further I have published a few more papers on it. Now we are doing in a lot of things are there that we are currently working on. In my next slides, I have few more slides related to chain of custody. Should I move to those slides on?
Yes, sir. Please, sir.
Okay, thank you very much. Again, I will see. Okay, so I have left from this slide. Okay. So these are things that we need to see. What are the benefits that we can get from this? See, the collection, preserving, validating, and other things can be strengthened with the help of forensic chain, means with the help of blockchain, because all the things are backed by strong security guarantees, right? Because we have decentralization there, we have integrity preservation there with the help of hash functions. Is my voice audible?
Yes, sir. Yes,
Yes,
sir.
sir.
Okay, so we are actually exploiting the blockchain by design features. Authenticity, auditability are there. So collection, preservation, validation, and all other things related to the evidences can be strengthened with this. it allows us to prove any event that has happened and that has arisen in the cybercrime investigation, because it records each and every action right from the source of origination. So we need not to bother about what has happened after this and what has happened at this time if we have built the things on the blockchain, because we will get each and everything. This is the strength of the blockchain that we are exploiting here. Now, it also helps us to provide transparency by reducing the frauds, because we are building a strong audit trail, and this is not restricted to only the forensic cases. We can build the audit systems itself in organizations with the help of blockchain. These are the things that have to be exploited, because the blockchain is best in these things. Again, there's no involvement of third party, only authorized entities are there, consensus is there. People are defining blockchain as trustless technology, but the best thing to define it is trustful, but it is based upon distributed trust, trusting everyone in aggregate, either in a group of quorum or a slice of quorum is agreeing on it, and there is a distributed trust. Maximum people are agreeing on it, just like in case of Bitcoin model, we have proof of work, and more than network power, network hash power is more than 50%. Okay, fine, he's able to win and he is able to produce. That means it is related to a distributed trust, not trustless. When some say it's an analogy, there's no problem in explaining it in that way also. Again, it can act as an auditing tool, and that assures the correctness processes and the procedures used by the tools itself. Because if we put tools onto the blockchain, and we can be assured about their functionality, what kind of functionality they are doing, while doing analysis on digital evidence, or while extracting it, while seeing the state of the system itself. If we are using blockchain, then these things are assured with this, with the properties and with the features that we are using, exploiting with the help of blockchain. Again, organization have another advantage of using this, because verification and action within the evidence record itself is, it enables us to build the trust, because this is happening with the blockchain. So we say, okay, there is a trust, distributed trust inside it. Now, another very, very important function benefit that we can reap out from this model is it allows the possibility of cross-border forensic investigation. Maximum times we see, there are, provided we have, standardization on cyber laws in different countries, then we can come up with this model that helps us to, to mitigate cyber crimes all over the world through this blockchain, because this can easily help us to track digital evidence is happening anywhere.
நான் இதுலயே வச்சுக்கிறேன்.
That this feature is very important, because this opens up a new world of investigation, because mostly, the person who are doing in crime in one country, cybercrime, is not liable to the laws, holding on other country. So that thing can be, handled with this model. And maybe there are news is coming in that, FBI and all that, they are, Interpol are, building such systems so that they can track any culprit and sitting anywhere in the world. Okay, now talking about the state of the art. I have already told you that we started this process in 2017, and that time there was almost, to the best of my knowledge, no paper dealing with this. And currently, I performed a very thorough systematic literature review on this, and I came to know there are multiple papers on this and targeting single thing, like how to use blockchain for digital forensics. And I just prepared a taxonomy here, so that to get the idea of where blockchain forensic is being used in different sort of application domains. It has been used in cloud forensics, where to store or to preserve the evidences on the clouds, because more and more people are connecting to the cloud and using the cloud-based services. And with the digitization coming around, maximum people are building things on IoT, using digital devices connected to the internet. So the forensic thing can really help out in building that forensic chain model for cloud forensics. In IoT, there is the same case, because the number of IoT devices with the time is growing exponentially, and maybe it will reach to 50 million according to the sources in the literature in a couple of years now. In healthcare, they have used it. In generic sense, they have used it. In generic sense, what I mean here is some papers have proposed the models for building data management and building some functionality of forensic things here to prove, integrity of logs and to build the chain of custody that I have explained in the session already here. So a lot of things are going on in this space, and it's a very, very bright, road ahead. We can do multiple things here. Okay, now the case is what limits blockchain to just extract maximum benefit out of it. Now I will explain these things in one by one. First thing is scalability. As in any other application, here in digital forensics, it also limits the potential of blockchain. But fortunately, multiple proposals are coming out and multiple types of blockchains are there that can be used to target the specific applications, with blockchain. Scalability can be defined in a very basic sense, that how model is able to cope up the the demanding requirements with the time, or demanding, maybe a simple example be multiple the devices are going onto the system and more and more number of users are using. So how it behaves and to this demand, it is defined by the scalability. And there are two things associated with it. One is throughput. Throughput is just how many transactions per second we are able to commit or we are able to confirm. And this is a very, very important thing to understand here, because Bitcoin as an application of blockchain has a very limited capacity, limited ability, and the throughput there is maximum it can reach up to the 7 TPS transaction per second. And in the same cases with the Ethereum, the public Ethereum I'm talking about, it is, it can maximum reach about 12 to 15 transactions per second. That's not going to help us anyway in forensics, because maybe there are hundreds of transactions, happening, and it may lead to delays and all the latencies there. So we require a solution, a very immediate solution for this. This is one part of scalability where transactions are taken into consideration. Another part is to deal with the storage, because transaction itself contains, has some size in bytes, and with more and more transactions going on, it adds some data. Because here at the very first slide I told you that it's not a database, it is just a distributed system where we have to minimize the data we are putting into the blockchain. But still, if we simply do a transaction, that also has a cost associated with the storage, even in bytes. So if we build as part of the research, we build some equations where we can use to determine scalability in terms of storage, the number of transactions per year, what is the header size, all the things can, we can use that to just measure the strength of blockchain in terms of its scalability. So here we also require some immediate solutions, because this can also bring bold to blockchain, where after that, because even though storage is not too costly now, but seeing the nature of those constrained devices like IoT devices, we have a limited storage and they cannot act as a full nodes then, because what I meant by full nodes is that those nodes which store whole of the blockchain itself. So then they again cannot take part in the consensus mechanism right away, because only full nodes can do that. So this again creates like it moves towards the somewhat decentralization. No, apart from being a truly decentralized like we have in Hyperledger or any other private blockchain. Another part is lack of standardization. There is no defined standard what kind of things we have to build, what kind of surety we have to provide, what kind of procedures we have to use the blockchain in itself. If we take forensic application also into consideration, there's a lag in this, and the research is going on towards this because standardization required, and those laws also have to be taken into consideration, and we have to build the solutions according to those also. So I will come to the questions one by one because we have enough time to handle all the questions, right? No problem at all. Interoperability is again an issue that Hyperledger solves most of the problems related to this, but still, if we are using one type of private blockchain on Ethereum and someone is using other, then we have to collaborate. This again creates some problems. We have to require another sort of advanced research into this direction to make it seamless and very portable and interoperable. We should be able to communicate with each and everyone. Maybe they are on different blockchain. Now, what are some challenges that were in the previous slides I have discussed? What limits the blockchain? Now, what are specific challenges that pertaining to this digital forensics blockchain is facing? Again, there are multiple artifacts about the blockchain, like the digital signature verifications, the place where the digital evidence is being extracted, and other subtle and important features of the digital evidences. So we have to use tokenization. We have to map different artifacts to digital evidence itself. So it's very hard to break down the things and then again storing them blockchain. And it's not a trivial problem here, because here I have simply used a simple basic application of it. But if we do it on a large scale, then we have to take care of this also. Volume of data pertaining to digital sense also may hamper to the efficiency, as I have talked about the scalability problem in terms of storage. But fortunately, we have off-chain solutions, but we have to take care of the security also, because IPFS stores in plain. There is no encryption, but we can use any advanced encryption mechanism to store the data in off-chain storages, like we have interplanetary file systems, IPFS. We have storage, cloud-based storage. We can efficiently exploit those features, and we can build a very strong forensic model based on blockchain. International in adequate functionality is also required because proper standards and procedures are missing. So it's very hard to simulate all the functionalities. There is a human part also involved in this, where we have to trust somewhere into this while collecting evidences. That is also to be taken into consideration so that this becomes seamless and fully automated. International operability is also there. International standards are lagging. There is no such coming standard flows so that we can build and we can have proper data sharing mechanisms. Future prospects. This is the future work that anyone can work on it, because we are working currently on blockchain driven forensic as a service, where we are using blockchain as a service for digital forensics, and that can help us to build blockchain driven forensic as a service, where I will just give a gist about it. We are building, we can build plugins, we can integrate into forensic tools, right? Every action and every process that is happening within the tool itself, that is also being recorded into the blockchain. Authentication is done through blockchain driven access control mechanisms, and this is what in future we are trying to build in. So very solid and integrated mechanism, integrated framework that will involve each and everyone. Police department, court, prison, blockchain network is there. Each and everything is there. Like who is going to handle the blockchain, who is going to set up the blockchain, who is going to maintain the blockchain and taking part into the consensus mechanism. These arrows indicate that. this is trusted authority or any investigation agency that is responsible for setting up the blockchain. And we have participants again, and that they are doing transactions to and from blockchain. This is,
Excuse me, sir. Excuse me, sir.
Yes, please.
Sir, can you explain this once again, sir? Integrating blockchain-driven access control for authorizations.
Yeah, I have a few more slides, fortunately, for building an access control mechanism for authorization. I will tell you each and every step how we can build access control on the top of blockchain, right?
Yes, sir. Yes, sir. Thank
And
you.
in for the slides, I have taken this because this was not part of the agenda, but I still feel, because as a generic heading, I have written blockchain for digital forensics and cybersecurity. And one of the important security mechanism is access control in itself, because this is related to authentication and authorization. We
Yes,
see.
sir.
Okay, now another, yesterday I was listening to the estimate professor about the digital certificates. How can we prevent the forgery in academic certificates? This was also the part of the research that we did here in NIT. So we can take it to the next level and build the solution for the Indian education system, because fraud in issuance verification of academic certificates have been a long-standing issue in academic community. In this present era, there are multiple fraudulent certificates roaming here and there due to lack of anti-forgery mechanism, not having solid mechanisms. We are having substantial increase in fraudulent certificates. And there's a need of our to have a very solid, transparent, and reliable model. And blockchain has that properties, because decentralized, auditable, and tamper-proof properties of blockchain makes it possible. Possibly the best choice to build the integrated solution for maintaining the integrity and preventing the fraud in academic certificates. In the next slide, I am giving my own proposed model here. This model fits to the Indian education system, because if we consider higher education regulatory authority, that may be in technical institutes, we have AICTE that may be sitting at the top, right? And we have higher education institutes, maybe STTP, maybe one higher education institutes, and other institutes all around India. They require authorization as part of their approval from AICTE, right? Then they are allowed to issue and revoke certificates based upon their registration for what courses they are able to do it, they can do it. And this part is the authorization part that is happening between higher education regulatory authority like UGC or AICT with the higher education institutes. Another part is certificate issuance that is happening between higher education institutes and the different institutes, and the students who are studying in those institutes, they will be issued, and maybe they will be revoked certificates based upon the scenarios. And again, we have smart contracts based on Ethereum, and there is no problem. Another blockchain can be used. Hyperledger Composer can be also used there. Hyperledger Fabric even.
Can I ask a question?
Yeah, please.
Actually, during all this blockchain and smart contracts and everything, I really wanted to understand more about the legal aspect of it, and how are we supposed to use it in law if we want to implement it. The kind of explanation which you're doing for forensics and all those
Yeah.
systems, I have been learning about it, but it's very new for legal fraternity, and how to make it much easier for them to understand that this is going to help us in in properly putting things, and probably being more authentic by putting it through this particular process of blockchain and making it through smart contracts. Could you please explain some shed some light over that? How is it
Yeah,
going to be helpful for legal fraternity?
Okay, yeah, in technical aspects and being legal, there are some laws and issues there. So we need to understand first what the traditional means they are doing, how they are making it admissible in the court of law, how digital evidences are produced there. Then we have to take each and every step into consideration, how blockchain is doing it. For that, we have to understand the cryptography, how cryptography is ensuring, integrity, authenticity, and like digital signatures are there. So we need to understand those parts also in And this subject also requires legal experts here in terms of technical things I'm explaining here, but maybe I'm missing about the legal things. So that requires further discussion and further research from the legal persons also. And whatever I can explain here is about the technical things and the things that we require as part of the digital forensic model framework. I hope this is, you get the point here, because legal
Almost,
thing.
because no, almost, but then I really expected to know more about smart contracts because I have been working on those,
Yeah, absolutely.
and they
There
are
are,
very much legal in picture. But
yes, yes.
then
There
only
are
thing,
multiple resources that you
it'll
can
take
get.
time, and obviously both
Yes.
experts have to be present to just discuss about it.
Yeah,
No worries.
I'm
Thank you
I'm
so much.
taking into consideration about the technical aspects, but there are very very good articles on the in the literature which explain about the legality of smart contracts itself, right? So that will be a very interesting things to read. You can just search on those. Ethereum smart contracts are very very often used for doing those things. You can go on the literature and just see this is a very interesting thing, and both of the experts are required to settle those things. Here again, in coming back to this slide, we have again now the query from the investors arises that we have already issued the certificates. How to bring back those onto the blockchain with that timestamp? So that requires export functionality, so we can export those things from database and put onto the blockchain through Ethereum smart contracts. And this is the second part. We have blockchain that are going through the blockchain now. Again, those peer-to-peer networks, that is strength of the blockchain. We have a consensus mechanism. If everything goes right, then they are put into the blockchain. Now we have the third part is verification. Verification, there are multiple verifying parties that want to verify the authenticity of the certificates. They can again invoke Ethereum functions, just like any other functions they are using. And the response will be whether this is authentic and at what time he has been issued that certificate, and what are other parameters that are important to verify their claims. I hope this model is clear to everyone. If is there anything to explain in this, I will move to a very important topic here. I think it's okay. Should I move to next slide?
Yes, sir.
Yeah, thank you.
Please. And in between, it's better to ask questions in the last because that might be the better. We will be providing chances to ask you all questions. Please let him
Yeah,
proceed
sure,
with the.
sure. No issue. We will take on the question at the last of this session. No problem at all. Thank you. So, what are the benefits that we get from this model that I have shown in the previous slide? Credentials, set not only the academic ones, other official documents, office documents, uh, and this just they become immutable while putting onto the blockchain because of the cryptographic hash functions, trustful because of this consensus mechanism, verifiable because of that transparent and very solid audit trail properties of blockchain. It also simplifies the workflow of certificate issuance and verification, making whole process efficient and economical. There are other benefits that blockchain helps us. It can transfer the education industry. If we take whole of the academic or courses into the blockchain, where degree and credits all that are same, making it more efficient, transparent, democratic, and secure. Even we can extend. There is a possibility of extension to we use it for authentication of and authorization of other official documents, statements, or files that we have. Now, as part of blockchain for cybersecurity, the slide from here on, I will take on that portion, and where blockchain has been used for security purposes. And for that, again, a solid and very thorough literature review has been conducted by our fellows and me also as part of this research. And
Hello, Akib. Hello, Akib. പോയെഴുന്നേറ്റ് Hello, Akib.
Yeah.
Are you there?
Yeah. Is my voice audible to you?
Yeah.
Yeah. Apology for
It's okay. It's
that internet breakdown here. Unfortunately, it was at the end of the session. Thank God. There is a very weak Wi-Fi connection, but still, I hope I may be able to finish on the things.
okay.
Am I audible to everyone again?
Yes.
Sorry.
Yes, sir.
Yes, you are audible.
Yeah, thank you. So again, I will just take on from the slide that I have just left. Okay. So as part of blockchain for cybersecurity, where we conducted a thorough literature review about what security services have been built on the blockchain, and interesting facts are being revealed here because it has been used to several things. But what is important is here the traditional security mechanism are there, but they have exploited decentralized, auditable, integrity preservation, strong features of blockchain to build a very solid security mechanisms. And at taxonomy here, we see there are certain security services that have been built for IoT in particular, and in general, if we talk about it's for based applications. So they range from access control, audit trail, authorization, integrity, secure key management, secure provisioning, securing against denial of distributed denial of services, several other security mechanisms. And one interesting fact is maximum research was conducted towards access control, and that focus, and we conducted again we just take on access control into account and see what access control mechanism have been developed particularly for internet, because internet of things, because this is a very promising field where blockchain is extensively being used. Okay, so this was the distribution of those results, and interestingly, we have access control 22% is only focusing towards access control mechanisms built on blockchain. So we take this access control into account and do it again a very strong review of those mechanisms that have been built on this. Right. So blockchain driven access control mechanism for IoT. So what was the requirement building blockchain driven access control mechanism? So in sense, what motivates us to move towards blockchain for building a very solid access control mechanism for IoT devices? First off, we see the scalability problem, because there are a large number of devices connected to IoT. It just increases drastically management overload in access control systems, and we have heterogeneity. IoT systems are, there are multiple devices of varying technologies, application domains. So it really brings the heterogeneity into the consideration. So access control has to be, very adaptable in such scenarios. Limited resources, again, we know IoT devices are and very lightweight. They don't have that capacity in terms of competition and storage. So access control has to think about, access control has to dynamically adapt for this also. Context awareness is there, because access decisions in IoT environments have to be dynamic and context based. Context, I mean, like surrounding environment is there, like temperature is going towards 30 degree or more as an example, and what behavior we have to show, and behavior of the device itself. So all in all, access control mechanisms have to be very adaptive in IoT particularly. So the traditional access control mechanism that we have are centralized in nature. So they are very less scalable, and they are not able to meet the requirements of the IoT constraint resource devices because of having a shortage in computational power and storage. So first, if we simply define access control, this is ability to control who can access what, under what conditions access should be granted. So this is very important security measure, because this is the first step towards building a very secure environment based on blockchain, because this access control is related to the authorization after authentication. Once the person is being authenticated, that can be also built on the blockchain, and after that, what services it can acquire, what actions it can perform, this is all you know all done with the help of all controlled with the help of access control mechanisms. Access control in IoT, it's a critical problem because of security and privacy issues in the complex IoT environments, because of the because of underlying technologies in IoTs, the multitude of IoT devices connected to the network, and their dynamic topology, like there is no fixed set of network topology that we can map in advance. So this really poses new and unique challenges in front of us to develop a different sort of access control mechanism. So what blockchain-driven access control in IoT brings in, the flexible nature of blockchain technology, it makes a very, very universal risk when blended with other technologies, because set of features of blockchain like decentralization, power of guaranteeing authenticity and integrity, we can just mix up with other technologies and build a desirable results. It helps us in eliminating single point of failure, because there is a distribution of the transactions or the transaction data, and that is distributed or replicated to several nodes, and there is also a decentralization to, so it eliminates the problem of single point of failure, where in traditional access control mechanism we were having a problem of centralization because access policies were enforced by a central authority. If that goes down, then we may have a breakdown, even if we can have replicated or any alternative mechanism. But blockchain has a very powerful feature of replicating things to multiple devices and giving us a service 24/7 without any latency or any delay. Access policies can be enforced dynamically with the help of smart contracts that we have seen in case of chain of custody, where we have used smart contracts efficiently. We can use those to build the policies for access control policies to enforce access controls in IoT also. There are like one point that is important to discuss here is to see the difference between public and private or consortium blockchains. One is very efficient in like multiple devices can connect without any restriction, like public blockchains, multiple nodes are connecting, they are scalable in connecting this, but they are not scalable in terms of throughput. But in if we talk about these private blockchains, they are scalable in terms of transactions per second, because they can support up to thousands of transactions per second, but they are not scalable in terms of the devices that are taking participation in building the consensus, because most of those like hyperledger fabric or any other proof of authority, their consensus mechanism is based on practical Byzantine fault tolerance consensus, where there is a requirement of in the formula is 3f plus 1 It can handle F for faulty nodes if we have 3F+1 total nodes. So with number of nodes coming in, it becomes very difficult for those access control, those consensus mechanism to guarantee the security. So there should be a balance about using any particular type of blockchain while targeting any particular application. We can build access control mechanism based on private or consortium blockchains itself to meet the scalable level that we require in case of IoT devices. Again, it brings all those features that blockchain by design provides, like transaction origination and auditability. And the next one will be, if we dig deep again into those methods that have been built for IoT, blockchain-driven access control, we came to know there were mechanisms that were capability-based, that were attribute-based. All in all, what those papers have proposed is to just exploiting the blockchain's capability, smart contract. This is a glimpse of those papers that have been proposed, that have proposed their access control mechanism for IoT based on blockchain. Some have just simply exploited the basic, like the power of smart contracts, writing access policy into it and building an access control mechanism. And most of the solutions have utilized Ethereum as a platform, followed by Hyperledger. This is probably because of the flexible smart contract language solidity and wide support available in terms of developing resources. In the same case, it is Hyperledger Fabric. And most of the solutions have just used simple generic access control models by extensively exploiting blockchain smart contracts or chain codes for enforcing policies, because they are building the solutions based upon the decentralized property of blockchain. Some solutions are also drawn motivation from the traditional access control mechanism, like attribute-based access control and other systems that they have built the solutions based upon capability or attribute-based policies and develop access control for IoT based on blockchain. Okay, so let us summarize the things that I have discussed here. Blockchain has capability to establish a distributed trust among entrusted parties. Blockchain has very beautiful feature that it provides us the proof of state. State can be of ownership, it can be of proof of existence, and other features that we have discussed. Before, one important feature, one important aspect related to blockchain is, before putting into the practice those models, we need to evaluate those models in terms of cost, security, and scalability. Blockchain-driven access control mechanisms have shown promising results over the years. They thus making them the best choices and potential candidates for modern access control systems that currently we are, that are promising in nature, and we are in demand of those models for building access control mechanisms for IoT in particular. Blockchain technology requires a maturity in scalability and interoperability for mass adoption, because if these two issues are solved, and then no one can stop blockchain technology from becoming persuasive, like in case of IoT we have. So thank you. There are questions. If anybody is having any question, please post on the comment and chat section. I'm here to answer. Thank you. Should I take those questions?
Just a minute, Akif. Right.
Okay, no problem at all.
Sir, excuse me, sir.
Yeah, please.
Sir, you said IPFS is an offline, off-chain storage. What does it say?
Yeah, this is different from the things we have discussed here. It is again like distributed, storage, where mechanism is not like traditional storage is based upon the address, like the URL we are typing in, it is based upon the address, but here it is based upon the content, right? That's data is being stored based upon by hashing it and storing based upon the content, because hash is directly related to the content. Then these contents are distributed in and split it into blocks or in segments and replicated to multiple nodes. When we just try to retrieve, we have to retrieve with the help of this unique hash. So it is content based addressing rather than address based addressing in IPFS. And more for this, you can just search on IPFS, and there are plenty amount of documents available over the internet. You can just please search on for this.
Yes, sir. Thank you, sir.
Thank you. Okay.
If these are the questions,
All right. All right. If anybody is having any other question, please let me know. So first question is, I want to know about the BAS, what technology you have to use to provide BAS. Okay. This is blockchain. Actually, it is blockchain as a forensic service, right? So for this, of course, blockchain is required, but there are certain other things like we have to develop a plugin or any other tool that can be integrated with the softwares that we have for forensic softwares. Like we have NCase, we have FTK. We can integrate those plugins and connect with the blockchain and build the solutions and use the blockchain as a platform, right? So this is a very broad question. It can take lots of time to explain, but here we have different sort of technologies we have to just integrate and build the solution. I hope I answered that question. Now the second question is, which platform we use to simulate IoT authentication algorithm? Again, with blockchain, you have the choice to use whether Ethereum, or you can use any other private blockchain or consortium blockchain. For that, you have to just simulate your logic in terms of chain code or smart contracts. Like a simple example is that you want to give access only to certain people with certain amount of feedback or any reputation. You can just build the logic for that, and you can just deploy those contracts to the blockchain and integrate all the devices to the blockchain and do the access check with the help of these chain codes or smart contracts. Question third is, what are the basic skill or language required to know the blockchain system? Okay, this is a very generic question and very good question. Even the skill you require, as blockchain is technological mix of different technologies. If we see, it is based on peer-to-peer networking, that is networking part. It is built with help of cryptography, that is security part. It is built with game theory, and that is dealing with the economics, and consensus mechanism, that is dealing with the distributed mechanisms and building trust in distributed environment. And the language you require to know, there are multiple languages. It varies which blockchain platform you are using. If you are talking about Ethereum, you can just learn Solidity. It is for writing smart contracts. Question 4, I have give some example algorithm related to generic control methods. Here I have used my own term as generic access control mechanism. Generic access control mechanism is, you have some logic in mind and you want to build an access control mechanism for that, but you have to just require to code it in terms of Solidity or any other platform like Hyperledger. And that's why I just say it as a generic. There is nothing special in it. There is not attribute, there is no capability. Simple, the generic mode of doing access control mechanism. In the existing signing protocol, okay, fine. Implementation of DKG, distributed key generation, right? Software best environment today. Put some light, distributed key generation. So it's, it may take some time to think upon this. So I may explain this. You can just have my email ID. I can provide you some details about this. Please share my email ID. I will share on the chat. If anyone is having any other, concern on any other question regarding their research work, they can reach to me at this address. I am sharing with everyone here. Okay. So because this is more generic in sense, and maybe it requires time to think upon what platform suits to build distributed key generation. If anyone is having any other question regarding the fundamentals, even we have still some time left, we can discuss that. I'm here for another 20 minutes.
Sir, I think the questions are over.
Okay.
So we could wind up the session.
All right, Umashu. Okay, once again, thank you very much for Professor Jubilant and Mr. Hari for inviting me here. So it was nice, and so it was pleasure to be here. Thank you very much again.
Thank you, sir.
Thank you. Thank you.
Thank you, sir.
The next session will start at 11:30. Decentralization Identity by Dr. Mukesh Mohania.
Okay.
Thank you, Akyut, for all your support.
Thank you, sir.